Thank you so much for this introduction. And thanks too for the invitation. So let me share my screen. So I want to talk about requirements. Before I jump into the topic, let me explain the logo, my first slide. So until 4 years ago, I was at ETH Zurich, but I'm now involved as a provost and professor of software engineering in a new institution, a new university which has been created in Switzerland, in the beautiful surroundings of Schaffhausen, the Schaffhausen Institute of Technology. We're still very young. We're just starting. We have 2 research chairs. One is mine in software engineering, and one is my colleagues, Maro Pegses, also in software engineering and verification. We have a few PhD students, postdocs. We are hiring. We have positions available at both levels, PhD students and postdocs, and we are very proud that we just launched our first own educational program, which is a Master of Science in Computer Science and Software Engineering. Our founder, pictured here, is Sergei Belousov, who is a successful entrepreneur and head in particular of Acronis, backup and security, a very successful backup and security company. The university is a private university, but it's non-profit, and it's strongly supported by the Canton Schaffhausen. In terms of our research directions, we have 3 major areas. One is computer science, to the left of this picture. The other one is physics, and we have very famous physicists, including a Nobel Prize in our scientific advisory board, Konstantin Novoselov, who is the inventor of graphene, and so advanced materials is one of the directions. And the third direction is the third major area is applications of digital technology to societal transformation, digital health, digital sports, and so on. So this is our context. Maybe I should change. Well, sorry for that. So I've always been interested in requirements. But I have had in the past 2 or 3 years, let's say 5 years, in fact, a renewed interest in requirements in connection with a group of colleagues with whom we have formed an informal research team between the universities of Innopolis in Russia, Toulouse in France, and myself at SIT and Innopolis and Eiffel Software. So we've published several papers, in particular what I think is a major survey on the issue of formalism in requirements, which is now in the revision has been submitted, so we hope it will be published in the next few months. I'm also working on a book whose tentative cover is on the left. I think actually the picture will change, which tries to be a very practical description of how to do requirements properly. One of the reasons I'm interested in requirements is that it's kind of a bit of both worlds, the geek world and the non-geek world. So of course I'm a geek. I'm like the types on the left, and the kind of things that give me a kick are static analysis to determine that there will be no null pointer dereferencing at runtime, the absolute geekly stuff. But there's the rest of the world, the non-geek part of the world, and requirements is really the place where the 2 worlds, the geek world and the non-geek world, meet, because of course we are building software not just for our own intellectual pleasure, but to satisfy the needs of people in real world environment. So this is what makes requirements to me such an attractive topic, is that it straddles the border between those 2 worlds. It's customary to start any discussion of requirements by this citation from the famous book by Fred Brooks. I'm not an absolute enthusiast of devotee of this book in general, but this particular citation, which I will let you read and which is quite famous by itself, is quite appropriate. I should add to this that part of my work outside of my academic activities is to serve as a consultant, both for projects but also for legal aspects. So to serve as a software expert when company A is supposed to have developed a product for a software system for company B, and then 2 years later, the company B claims the system doesn't work, so they find each other in court and they call in the software experts. So it's something I do. It's actually quite interesting. And I was, for example, in a big case recently, and in that case, as in many others, often what you realize is that it's largely a matter of requirements not done rightly. People not taking the time and putting in the effort to make sure that the needs of the customer and the constraints of the environment are properly described and properly understood. So, of course, in my role as a software expert for the tribunal, for the court, I have a tendency always to think for myself, it's not really relevant to the public deposition, but I always think, why are they calling me now? They should have been calling me 2 years ago. I usually know the exact time from the document, from the meeting minutes in the case, out of the tens of thousands of documents. They should have been calling me 2 years ago when it was still possible to salvage the project, often by doing the proper requirements. It's, of course, usually not the only aspect, but it's a key aspect. So this is one more reason to pay more attention to requirements than people usually do. Requirements is another one of these cases in which there is a large gap, I think I can say a chasm between the state art in theory, in academia, and then what people actually do in industry. So on the theoretical side, we have a good understanding of requirements. We've had people like Axel van Lamsverde, like Martin Glintz at the University of Zurich, like Michael Jackson, Pamela Zave, others whom I will cite later on in the talk, who have done really great work in helping us to understand what requirements are about over the past 30 years. And we have some excellent books. So to a certain extent, why should I be writing a book now while we have these powerful and impressive tomes by experts in the field? I've only cited 2. There are more, but the Van Lamsverde book is more of an academic, theoretical book. The Wiegers and Beatty book is more of a practical, hands-on book, coming out of experience as consultants. They're very good, but they're not really applied in practice. So what you find in practice, really what passes for requirements in the industry when you go around, it's just one thing. It's use cases. That's all that people do. They write a few use cases. So I'm not going to define use cases here. I'm sure that all of you, most of you, are familiar with use cases. Basically, they describe scenarios of interaction with the system. Like here, for example, the local system and a remote system. This is a chat room system. So this is nice. It's useful, but it's not requirements. I mean, it can be an auxiliary to requirements. Actually, they have a place in the requirements plan that I'm going to propose at the end. But they are really test cases. So the relationship of use cases to requirements is the same as the relationship of test cases to program specifications. And it's well known that the test cases is good, it's useful, but it only covers a very small part of the possible cases that drop in the ocean. And the idea that the entire industry is basically substituting these little scenarios for requirements is a little scary. In the agile development world, they have a variant of this, which is called a user story, which is even simpler. So it's a little piece of functionality, typically something like this. This is actually the standard format for user stories in agile development, like Scrum, for example. As a role, like your customer, I want to achieve some business benefit, like see a list of my recent orders. I'm sorry, let me start again. As a role, I want to be able to perform a certain function so that, and after the so that comes an organizational or a business goal. So here I can track my purchases with Amazon, for example. So believe it or not, this is how much of the world software is being specified right now by this accumulation of dozens, hundreds, thousands of little user stories. And, you know, I won't even start to criticize the limitations of this approach, but it's obviously very amateurish and very partial, and it's part of general spirit in the agile world of rejecting big upfront requirements, big upfront design, anything that you do at the beginning at the expense of immediately starting to program. So for example, Mary Poppendieck, who is one of the leaders of this movement, writes, and those things called requirements, they are really candidate solutions. Separating requirements from implementation is just another form of handover. Handover, by the way, is not a compliment, right? Handover is one of the sources of waste in lean development. So I analyze this, and this is an opportunity to do completely blunt unapologetic advertising for one of my latest books. I published a book on agile development, which, unlike most of the agile literature, tries to take a reasoned attitude towards agile methods and to explain the pro and the con, the good and the bad, the good, the hype, and the ugly, as the title goes. So this is essentially part of the ugly, this rejection of upfront requirements. And I've seen just too many cases, too many projects that failed because the people at the beginning said, oh, we're agile or upfront requirements. This is what your grandfather and your grandmother did. We don't do this. We start coding. We're writing user stories as we go. And I've seen too many cases like that in which, 6 months or a year later, the project ended in dismal failure. So this is just wrong. Now, I will come back to that citation later on, because actually not everything in what she says is completely wrong, but this general rejection of upfront anything is really detrimental. Another aspect of today's scene is the presence of standards. So there's a very old 1998 standard about requirements, IEEE 830. I still teach it. I think many people still teach it because it's as good as we have in terms, for example, of a standard plan, and it's reasonable. However, it is very dated. It's very partial, and I'm going to propose a much more modern and I think, and I hope, useful and extensive plan for modern requirements documents. The general situation of standards is pretty pathetic, I should say. I know I'm not very polite with respect to the venerable IEEE, but when I see a working group, an international working group, which labors 10 years to produce something like what's shown here, I'm a little bit skeptical. So the first citation is from the systems engineering standard from the IEEE, and it defines what a requirement is. So it's a statement that identifies a product or process, operational, functional, or design characteristic. I don't know about you, but I cannot really parse that sentence. Maybe it's my knowledge of English which fails me here, which is unambiguous, testable, or measurable, and necessary for product or process acceptability by consumers or internal quality assurance guidelines. So this is, of course, gibberish. It's total nonsense. But what's worse about it, apart from being total nonsense, I wouldn't take the time to criticize this if it didn't bear the imprint of a respected working group from the IEEE, which has literally labored years to produce this, and it's kind of the second or third edition. But what's really terrible about it is that it confuses the prescriptive and the descriptive. In an engineering discipline, you should first define what the concepts are, and then you tell people what to do, how to work well, what to do in a certain way. Okay, before you start with speed limits, you define what speed is, the ratio of distance traveled to time. Here, there's an absolute constant mix of the prescriptive and the descriptive. A definition should be descriptive, but here it says that a requirement should be unambiguous. Well, sorry, you've seen requirements, I've seen requirements, they're not perfect, they're human products, but they're still requirements. If they are not testable, not measurable, there's still requirements. You see this constant mix of the prescriptive and the descriptive, which is a sign of immaturity. It's extremely amateurish. And what I'm going to try to do in the next few moments is to provide you with much simpler but descriptive definitions. Same thing about this quite recent, I think it's 2015, requirements engineering standard, which actually it's, I said IEEE, but in fact it's an ISO standard. It comes from the IEEE, but it's an ISO standard. If you have $300 to, you can buy it for $300, the electronic form, the paper form is more expensive. So what's requirement solicitation? Use of systematic techniques such as prototyping and structured surveys to proactively identify, even without the split infinitive, it would already be jargon, and document customer and end user needs. So this is bad in so many respects that I don't even know where to start. Someone has in the committee obviously had as a pet peeve that to do proper requirements you need to do prototyping. Okay, but there are dozens of elicitation techniques. Why is this particular one? Well, it's because someone shouted loudly enough in the committee to get this in, and at some point the others accepted so that he would shut up. Customer and end user needs. What's really remarkable here is that these two terms, of course, are defined in the standard, but they're very partial. Customers and end users are just two kinds of stakeholders. So what it should say here is stakeholder, which is actually also defined in that particular standard. Why they didn't do this is probably because they did not update a 20-year-old version, because 20 years ago, maybe we didn't understand this. But this is of such a terrible quality that we really need to do something better. So that's what I'm going to try to do. I'm going to end with a recommended plan for requirements documents, but first we have to go back to the very basics and define the fundamental concepts. So first, the context. This is from an article that my colleagues pictured at the bottom and myself published last year. The context is that we're talking about a certain project in a certain environment to achieve certain goals by developing a system. So this is why I call this approach the PEGS approach. That we have the 4 PEGS, P-E-G-S, of requirements engineering. So the project is a set of tasks, a succession of tasks. The environment is the set of properties from the problem domain that constrain the project and the future system and can be affected by them. We want to achieve certain goals. So the goals are the business objectives. There's always, even in a non-commercial context, there's always some organizational objectives that any project is intended to satisfy. And to do this, we produce a system which is a software machine or a combination of software and hardware machine to achieve the goals in the environment obtained by developing the project. So this is the context, this is the framework. Now, in this in stating that context, we already said quite a bit. For example, I think if you ask most people informally what are requirements for a software system, they'd probably say it's something like it's defining what the system should do, which, if you think about it, is only 1/4 of this here. Maybe it refers to goals a little bit, but we should distinguish what the system does, which is the system, and what the organization wants from it, which is the goals. And we should also distinguish between the system and the environment. So this is a distinction that goes back to the seminal work of Pamela Zave and Michael Jackson about 20 years ago, late 90s, where they made it clear that we need to distinguish between two kinds of properties that are often confused in requirements documents, those which we can have an effect on and those which are given to us. So the ones that we can have an effect on, they are the system properties or machine properties. Sometimes they call it machine and domain instead of system and environment. So we build a machine and we say, for example, in the requirements, the gate shall close in at most 3 seconds. So this is a system property if we're building, for example, a railroad crossing system. On the other hand, in order to build this system, we need to know the constraints and properties of the domain, of the environment. So if we say, for example, trains shall be assumed to travel at no more than 300 kilometers per hour, then it's an environment property. And it's very dangerous to confuse the two, and often in requirements documents from people who have not understood these concepts, who have not read Zave and Jackson, you find the two kinds of properties constantly intermingled with each other. Okay, continuing with the definitions, and I'm at a very elementary level, but I really want to make sure that we work with concepts that have rigorous definitions. So a property is a Boolean predicate. Well, this is probably redundant. It's a predicate, with value true or false, which of course affects the project, the environment, the goal, or the system. So an example is all humans are mortals. This is true or false. We are only interested in relevant properties, those which are of interest to some stakeholder. And of course, we should also define the notion of stakeholder precisely. I'm doing this, of course, in the book. Here we don't have the time. Now, I lied to you 1 minute ago when I said that all humans are mortals is a property. It's not really a property. It's a statement of a property, because the property exists independently of how I express it. So here I expressed it in English. I could have expressed it in French. I could have expressed it in German or Russian. I could also have expressed it graphically by drawing a picture, or I could have expressed it actually, this is exactly how you write it nowadays in Eiffel, but this is mathematics, or it's the Eiffel programming language with exactly this syntax. So this is a formal description. So all these 6 statements are different statements, but they're statements of the same property. So a statement is a human readable expression of a problem, which can be mathematical, graphical, natural language. So we need to distinguish between the two. So with this, we have a definition of requirement, at least in the context of systems, particularly software systems. It's a statement of a relevant property of a project, system, or goals or environment. I'm sorry, this is a typo. I forgot to include the goals. It's a statement of a relevant project, system, goal, or environment property. So we have the fact that it's relevant, of course, is important, because there are lots of things we can say about the project or the system or the goals or the environment. We could say that 2 developers are called Jim. Okay, that's a property. It's a statement of a property of the project, but it's not relevant because no one is interested. So the qualifier relevant is important. In our paper, we also we go to great pains to define all the basic kinds of requirement. And I don't have the time to give you a detailed definition of all these components, of all these kinds of requirements. Let me go only through the first 2 or 3, and you can read the paper or simply the slides, which I will make available for more details. So we have a goal. I think it's clear. We have a component, which is a part of the requirement that says there's part A, part B, part C, or component A, B, C of any of the aspects, system, project, environment, and so on. We have a behavior. This is the traditional view of requirements. We have the tasks and so on. So the paper goes into great detail to explain exactly what are these different kinds of requirement. There are also other kinds of requirement elements. I'm distinguishing between a requirement, which is as just defined, and a requirement element, which is something that appears in a requirements document. So it can be a requirement, but there's also some kind of meta requirement element, for example, noise. So that's not in the requirements. Actually, that is in the requirements, but they shouldn't be there. Okay, people tell you too much stuff, often at the expense of telling you the important stuff. Silence. This is the reverse of noise. It's a property that is in the requirements, but should not be. Should not be. I'm sorry. I think I mixed up noise and silence. I apologize for this. I fixed my slides at the last minute. It was a bad idea. So silence is the first and noise is the second. Then you have a meta requirement, which is a part of the requirement that doesn't tell you anything about the system, but it tells you something about the requirements themselves. If I have a sentence that says the details about this will appear in section 5.3, that's not a requirement, but it's a requirement element. So of course, I will fix my slides before I make them available. So by the way, just to advertise for an old paper of mine, there's this paper whose major interest for historians is that it's the only known picture in the entire universe of me with a beard, which had this discussion, which I think is largely still relevant, of the 7 sins of the specifier. And I've certainly drawn from this old discussion for the more recent stuff. In that recent paper, the taxonomy of requirements that I mentioned, we also start from the definitions that I just gave to describe a number of relations that can exist between requirements elements. So 2 requirements can be disjoint, one can belong textually to the other, one can repeat another, and so on. And so this has the advantage that we can start reasoning precisely about requirements. And so if we go back to the prescriptive, I made this important point that we should distinguish between the prescriptive and descriptive. So right now I was on descriptive aspects, but if we go back to the prescriptive, we can give prescriptions in a rational, justified way, and we can express them precisely, for example, by saying there shouldn't be any duplicates, which has a formal definition. There should not be any contradiction between requirements. The properties should be homogeneous, that is to say, they should all apply to the same level, project, environment, and so on. So this is, again, the kind of thing that we do in the paper. Before I go to the plan, I would like to take just a few minutes to give you a few of the requirements principles that I've noted over the years from my experience. This is only a small subset. There are many more. There will be more in the book, so we're definitely on the prescriptive side here. The first observation is that requirements are software. Okay? The requirements really, they are not literature. They're not just technical documents. They are software, and they should be often they should be written like software. There are many, for example, mechanisms of programming languages are applicable to describing requirements. They should be subject to configuration management because, like software, they change. So we should treat them the same way we treat code, tests, or design. They are part of the software repository of a project. The traceability principle tells us, as is well known in the requirements community, that one of the key difficulties and challenges of requirements is traceability. That is to say, every element of implementation must come directly or indirectly from an element in the requirements, otherwise, why is it there? And the other way around, every element of the requirements must be reflected somewhere in the implementation, in design and implementation in other products. Otherwise, it's just wishful thinking. It's just empty words. So traceability is one of the most difficult properties of requirements to achieve in practice. In my work with the Eiffel Studio environment, I've devoted a lot of effort to implement traceability mechanisms, in particular through the Eiffel information system, which provides the ability to directly link elements of the code to outside external elements like Word documents, PDF, and so on. So this is part of the Eiffel Studio element. There's also another piece of work that is connected to this, which is a paper that I published a few years ago in the Fachschrift dedicated to Martin Glins from the University of Zurich, who is one of the big names and made many contributions to requirements. The paper is a little bit bizarre. I mean, it tries to be a little bit clever for its own sake, but I think the message it carries, not very effectively, is important. It's that we should not have to choose between variants of notations, between, for example, a textual notation, a formal notation, and a graphical notation. So what it does is to have a set of intertwined discourses in a single document with, as you can see here, formal text, which is in Eiffel in this case, natural language text in English, I'm sorry, I have trouble pointing, and graphical elements. Okay? All referring to each other. So this is what I call multi-requirements, and I think it's a very promising avenue, in particular, to avoid divergence between the requirements and the code. So coming back to the agile view, which I criticized earlier, Mary Pomponique, in fact, has a point when they say that requirements are candidate solutions. Well, to a certain extent, yes. And so I would say, so what? We're interested in solutions. We're not interested in problems. So this goes very well with this idea that requirements are software. So what I think she was really criticizing here is what traditional approaches have missed badly. You know, traditional waterfall approaches and even more flexible notions have missed, which is the fact that requirements change. So you can still have an upfront requirements phase. That's okay. But what is not acceptable is to freeze the requirements at the end and say, okay, this is the word of God and it's not going to change ever after. This is completely absurd. We need both. We need to produce requirements at the beginning, understood as a first approximation. They don't have to be perfect. They don't have to be complete, because we do want, as the agile people tell us, to move on to implementation as quickly as possible. But still, we need to produce these initial requirements. And then, second, we need to continue adapting them absolutely all the time. So the day they are produced, they're already obsolete, and that's okay. That's the way the world goes. So this is what we could call the Chicago voting principle. Write requirements early and often. You know, this is, of course, it's a very important aspect of this first principle, that requirements are software. What characterizes software is the soft part, and requirements are no different in this respect. Another aspect of this is that we are not stuck, certainly in 2020, we're not stuck with a traditional view of a single requirements document. We should be talking instead of a requirements repository, and we can have all kinds of elements of requirements. So we should be able to produce a linear form, but requirements are everywhere, you know. The requirements documents, they're in meeting minutes, they're in PowerPoint presentations, there are emails, they are in regulatory documents, they are in previous projects, documentation and code, they're in competing products. So what's really critical is to have a repository which contains elements or references to all possible elements that could in fact impact the project at the requirements level. This is a point that was made in a slightly different way in a 94 paper by Anthony Finkelstein, where he talks about the importance of what he calls pre-RS, pre-requirement specification material, which often gets lost in a project. So keep the requirements repository up to date. Let me say just a couple of words about formalism. So of course, I've done some, academics tend to work on formal requirements because this is a place where you can prove things, you have a form, you have theorems, you have definitions, and it looks academically respectable. And industry does very little of it. A little, in particular in mission critical systems, but not very much. So an example of, I mean, rather trivial, and I hope you will appreciate that it's meant to be a slightly humorous example, because it's not really shattering, is this email that I received earlier this year from Swisscom. You know, I have a subscription with, not Swisscom, I'm sorry, Sunrise. Wow, big mistake, Sunrise. They send me what they think is helpful advice once in a while, like this one which started 10.7% of all Swiss people move house, relocate every year. Well, you know, if you think about this, it's the kind of thing that you could find in a requirements document. It's completely unambiguous. It's completely ambiguous, right? Do they mean that there is a population, you know, 10%, you know, like about 900,000 people in Switzerland who move year after year after year, which is a completely possible understanding of this statement. Probably what they mean is number two, which is that every year a subset of the Swiss people, 10% of them move. So this is typically the kind of ambiguity that pops up in requirements documents and for which we need formal approaches. So here, the formalism would be to use, the principle is to use a formal notation, not for everything. This extreme is extreme, except maybe in some life critical, mission critical systems. You typically do not need to do this, but use a formal notation to specify delicate parts. And this is what I call the formal picnic. There was a recent blog article about this, or maybe last year. Do a formal excursion and come back. So coming back again to my old paper, it started from a simple specification, which from very complex specification, a new version of the previous one, which other authors, Goodenough and Gerhardt, had produced, saying the original specification by Pittenard was not good enough without any pun. And they wrote something horrendously complicated for a very, very simple problem. So what I did in that paper was to write a mathematical specification, but I didn't stop there. After that, I went back to English and I produced this specification, which is essentially the mathematical text translated back into English. So it's about in between, halfway in between the original very short specification by Pittenard, which was not satisfactory, and this very long rewrite by Goodenough and Gerhardt. So it's about, so the long one was about 4 times the length of the first one, and mine is about twice. It's twice as long as the original one. It is half as long as the Goodenough Gerhardt one. And this is this formal picnic, this idea that you start from natural language, you formalize through mathematics, and then you go back to English, retranslated from mathematics. It's something that I've practiced often since then, and I think it's a very useful exercise. So use formal versions to produce better versions in non-formal notations. My last principle before I show the plan is object-oriented requirements. So this would really be another talk of its own. So I'm just giving you a glimpse here. But the point is that use cases or user stories are to requirements what procedural programming, Pascal style programming is to object-oriented programming. So we invented object-oriented development, which is a structuring mode, which I think has been demonstrated to be by now to be more effective, especially for large-scale system development, much more effective than the traditional procedural way of saying you would do A, then you do B, then you do C. What we do in object-oriented programming is that we say we have type A, we have type B, and we have type C, and then we attach the operations to the types rather than the other way around. And if you think about use cases, what people do day in, day out, it's good old procedural description. And this is just not abstract enough. It's just not good enough for the kind of structure, the kind of architecture that we need for modern systems with extendability, reusability, and simply understandability. So this is this principle of object-oriented requirements, and of course in the book I will give many examples of how to do this. So I come back to the combination, if you like, of this talk, which is that I'm trying to put together many of these ideas into a standard plan, which in absolute modesty I'm proposing as a standard replacement for the old 1998 IEEE standard plan, and it's still evolving, but it has already undergone many refinements, and I think it meets the needs of modern projects. So it has 4 books: project book, goals book, I'm sorry, in the order: project book, environment book, goals book, and system book. So of course it corresponds to the 4 PEGS that I described at the beginning: project, environment, goal, and system. The word book should not be misunderstood. I am not imposing a linear structure with 4 successive books. Again, this should be understood of having a requirements repository What's important is that we have the structure somewhere into 4 books where the contents can be spread over the database, over the repository in many different places. Remember, it can be, some of it can be in emails, can be on PowerPoint presentations. What's important is that, one, we have a clear structure with this division, and second, that we should be able to produce a linear requirements document, a linear classical standard requirements document, because many people, many stakeholders will want it at some point. But we can have tools that collect the elements and produce these for books. So the project book, to start with it, has 7 chapters: responsibilities, who does what, impose technical choices. The company only uses Microsoft products, or to the contrary, the company only uses open source products, things like this, which you have to know. You like them or you don't like them, but they are part of the reality of many projects. Personnel, who is available to do this project. P.4 list of tasks. By the way, this approach can be applied to an agile project as it can be applied to a traditional waterfall project or a spiral project or any variant. I'm not assuming any particular life cycle model or development method. So the task could be traditional ones, requirements and design and implementation and so on, or it could be this sprint, that sprint, and so on. Basically, what are the tasks? Then the schedule, milestones and deliverables. Then probably the biggest part of the project book, the description of individual tasks. Risks, force mitigation analysis. This is where you can, for example, have a SWOT analysis, strengths, weaknesses, opportunities and threats. So this is the project book. It takes care of the project. By the way, there are strict rules as to which books can reference which other books. For example, the environment book, which we're going to see next, cannot refer to any of the others because the environment exists independently of the project, the goals, and the system, with one exception, which I will mention. So the project book can refer to everything else except the system, because the project should not be dependent on specific characteristics of the system. Coming now to the environment book. The environment book has the following elements: a glossary. This is absolutely fundamental. Any requirements effort should put a considerable amount of energy into defining the terminology of the field, including the most dangerous aspects, which are words from ordinary language, which in a particular field means something special. Okay. So glossary, the components of the environment, and then we have various kinds of environment properties, which I have not had the time to go into. Constraints are properties of the environment that the environment imposes on you, like the bandwidth is 100 megabits per second. Assumptions are things that you assume from the environment. They're not constraints, they are actually decisions. For example, I had this case of a train that is assumed to run at most 300 kilometers an hour. Effect, so this is the only case in which the environment actually can have an effect, in which, I'm sorry, the system can have an effect on the environment. Okay, the system can actually modify the environment. The simplest case is a payroll system. When you install the payroll system, of course, it will have an effect. It will change the way in which the company does payroll. And same thing for a cyber physical system. The very presence of the system may affect the environment, so we define it here. And finally, invariant. These are things which, in a way, are both assumptions and effects. They are properties of the environment which the system should maintain. Third, the goals book. So this describes the organizational perspective. Maybe I should have started with it. Project context and overall objective. The current situation, an analysis of the current situation and obviously what's wrong with it, which we are trying to remedy. Then the expected benefits from the project. then an overview of the system. This is kind of a very short capsule version of the system book, but just to give an idea of what the system is going to be about. Limitations and risks. Stakeholders. It's very important to define all the categories of people who might affect or be affected by the system. You shouldn't forget anyone. This is the requirements are really a place to do this and to make sure we don't forget anyone who might be affected in particular. And then a list of the requirement sources, as I said, emails, regulatory documents, a memo by the CEO 5 years ago, which defined the directions of the company. Finally, the system book, which is what people traditionally think of as being the requirements. So first, general characteristics. Chapter 2, the list of components of the system. And then in S.3, which typically will be the biggest part here, the detailed functional and non-functional descriptions of the behaviors of the various components. Then something which is also very important, which is prioritization. One thing that you do not want to do, but people to do all the time, is not to define priorities between the various functionalities expected. And so, of course, something happens, the budget gets cut, there's a delay, and you have to cut some functionality, and you do it in a panic at the last moment, and or the programmer does it based on his criteria, and often it's done in a very bad fashion. It's not the right things that are sacrificed. So you need to know ahead of time what is essential, what is important, and what is nice to have. And then this is the place where you will have the scenarios, the use cases, which to validate the requirements. The use cases are not the requirements. There are ways to validate the requirements like tests, and it's very important to have them here in S.5. So this is the plan that I'm proposing. A couple of observations before I close. I'm not assuming a linear document. We can produce a linear document, but it doesn't have to be written as a linear document. So the elements can appear anywhere, but they should be recorded in the requirements repository. There can be tools that produce a linear version, and we're developing that kind of tools. They will be available together with the book. There will be templates. I will provide a Word template, maybe a FrameMaker template, or LaTeX template for the standard plan. And my book is relatively short and theoretical. A book theoretical, I shouldn't say theoretical because it's very practical, but I should say conceptual. It only has short examples, but with our team at Innopolis University in Toulouse, we are working on a really large example, a software for cars system, which applies all the ideas so as to have a large-scale illustration of it. Okay, so this is what I wanted to present. There are a number of references. Before I share my slides with the organizers, I will put more precise references and URLs where they are available. I'd like to thank you for very patiently listening to me and watching these now 45 slides. Of course, I don't know if any questions are planned. I'm certainly happy to answer questions, and I'm also happy to welcome you at any time in the beautiful, at least when we can travel a little more easily than we can now. I'm quite happy to welcome you in the beautiful surroundings of the Schaffhausen Institute of Technology.
Thank you a lot, Professor Meyer, for this very instructive talk. I'm asking people from the discussion group, maybe they have a question, or I'm also trying to look into the chat if there are questions appearing. Let me start with a simple practical question. You have depicted the full picture of how requirements should be handled. and apart from people getting people to really do the full picture, of course, certain parts of requirements are more difficult to formulate than others. In practice, where do you think have people the biggest problems or also the biggest opposition towards the scheme you are presenting?
Well, it's a difficult question. It's a very good question. It's a difficult question. So what are the most difficult parts? One of them is not forgetting anything important. This is one of the biggest risks, you know, that there is something which is unsaid, which no one tells you. So there's a certain, in the activity of requirement solicitation, there's a certain dose of pulling teeth, right? People do not necessarily come up with all the information naturally, so you have to go and probe and probe and probe. So this is the reasons why we have professional business analysts or requirements engineers, and depending on the industry, they're called one way or the other. They know how to get people to tell you what they're not telling you naturally, because it's obvious, you know, all that stuff which is supposed to be obvious because everyone in the field knows it, and so it's not going to be expressed to the development team. So that is one of the difficulties. Another of the major difficulties is to get important properties in a precise form. So this was my little exploration of the use of formal methods. I think one of the difficulties is that for some reason, many people, in particular in business informatics, and I'm referring here, of course, to the previous session on business informatics and its teaching, which was very informative and from which I learned quite a bit. So in this area of business informatics, in my experience, people do not naturally think of using formal methods. And in life critical systems and mission critical systems, at some point over the past 20 years, people made the switch, you know, decided you could write a quantifier and it would not give you a bad breath. Okay, it would not destroy your love life. I think that's okay in that community. In the business informatics community, in my experience, people are still a little scared of using mathematics, but mathematics is the only tool. It's the only rigorous reasoning tool that we have, and so that is one of the difficulties, to have people who will actually make the jump and start writing enough formal descriptions. Not too many, but enough. And a third, I'll stop at 3 because I could continue, but I don't want to give too long an answer. It's already a long answer, sorry. But let me just mention another major difficulty, which is traceability. You know, one of the reasons the agile people were so negative about requirements is that often in a traditional environment, a big effort is devoted to writing these huge requirements documents, and then no one reads them. They sit on a shelf somewhere, and there tends to be a kind of a disconnection, you know, Dorian Gray phenomenon except that it's reverse Dorian Gray, between the implementation and the specification, with the two diverging completely at some point. So traceability and updating the requirements, and we actually divide them into two. Number 3 is traceability, and number 4 would be updating the requirements, convincing people that the requirements are not a dead document. They should be a living document that you update and update and update.
Thank you. I have got 2 questions or comments or something in between. I'm reading the one from Martin Klintz, who is in the audience. Thanks for the great keynote. I'm missing another principle: requirements need to create value. And he says that depending on the criticality of a thing, we might need more precise or more detailed requirements, or we can go with more coarse requirements. What's your perspective on this?
Yeah, hi Martin. Of course, this is an opportunity to highlight the great contributions that Professor Martin Glitz has made to the field. My short answer is yes. I did not claim to include all requirements principles. I just included a few. I shone the light on a few important principles which go well with the rest of the talk, but there are many more, and this principle of creating value is an important one, and I'll make sure that I include it in the book.
Thanks. Then we also have one comment from Oskar Nierstrass, I guess. He says it's a very interesting breakdown, but it seems that many parts go beyond requirements. So he thinks that he asks a question, basically raises the question whether this doesn't go very much beyond what we understand by requirements. And I can well imagine that people in practice might perceive it like that as well. So what would be your answer on this?
Well, first, I'm very honored to have the whole pantheon, some of the pantheon of Swiss software engineering in the audience. This is a bit intimidating, so thanks, Oscar, for this question. I think it's possibly controversial. My view of requirements is that the requirements should cover these four aspects. I think it's legitimate to say the project is not covered by the requirement, but I think it should. And of course, there's going to be lots of project management aspects that do not need to be in the requirements document in a broad sense of the word document. But I would feel that the requirements effort is lame, is not complete, if it ends up specifying the environment, the system, and the goals, but leaves out the project part. It's going to be a little bit like hand waving. A successful requirements effort should, in my experience, include some of the tough questions related to the project, because otherwise you can always promise the moon. You can describe a system that will do everything plus coffee in the morning, but writing the project book forces you to be realistic, to attach figures, budgets, deadlines, tasks, people. Without this, the requirements are too partial. Where I follow you, where I agree with you, is that there is a limit to this, and the requirements document does not have to encompass the entire project management plan, but it should have the basics of it.
Thanks a lot for this, also answering the questions. I think I would personally like very much to continue listening to this dialogue, and maybe some people can put further remarks, questions to you, and you would be willing to take them up. I mean, we can also
absolutely
at the end prepare them for you that who wanted to know what. Thanks a lot once again, and I think I know it sounds not very well if just one person is applauding, but thanks a lot.
Thanks.
It was a very, very instructive
I
talk.
appreciate the opportunity very much.
And we are proud you were with us, and I have to announce now a 5 minutes break. And in addition, I have to apologize myself because we had a problem with quarantine with one assistant. and we have the General Assembly this afternoon, and so I have to rush to the Berner Rathaus for the General Assembly. So I apologize that I won't be able to announce Daniel Stoller-Schei and his panel, but I hope then from the Berner Rathaus during his panel I can get back to the digital summit. So we have a 5 minutes break, and then looking forward to all the next, and many thanks again Professor Meyer for the very instructive and engaged presentation of your view on requirements.
Thank you very much too, on my side.